everyone knows a major factor in success is confidence. The more confidence we have in the things that we do, the more likely that we are to succeed. Prototyping is no different. In fact, the high level of uncertainty and ambiguity and the fast pace of prototyping depends a great deal on the confidence of those involved. At AWS, we talk a lot about innovation. And one of the key drivers to cloud adoption is the ability of our customers to innovate faster and more often. But adopting the cloud is just one part of this innovation equation. I am Jeremy Jonas, a senior prototyping engineer here at Amazon Web Services. And today I would like to take you on a journey that will unleash more innovation potential in your company through the use of mechanisms and modern tooling to streamline your prototyping practice, improve your agility, and provide more control. In short, provide you with more confidence in your prototyping. Through our experience working with hundreds of customers across lots of segments and industries, our prototyping has honed these mechanisms and tools that drive successful innovation. This is level 300, so we will definitely dive deeper into the tech and walk through some coding examples. But first, let's take a step back and understand what we mean by prototyping. Make sure that we're talking about the same thing. And look at the mental models and higher processes that, when applied to prototyping, can really increase this elusive thing we call confidence. If you caught my previous session, Effective Prototyping Beyond the Science Experiment, you will see a common thread between these concepts that drives our methodology of prototyping here at AWS. So first, let's get on the same page about what prototyping is. AWS takes a slightly different perspective on prototyping than you may be familiar with. There are many terms that people relate to prototyping: POC, proof of concept, experiment, demo, MVP, alpha, and so on. Here at AWS, we draw that gray, fuzzy line between prototyping and these other forms as being focused on business outcome rather than technology outcome. Science experiments for solving real-world business problems. For example, the difference between experimenting with connecting a forklift to the internet, a technology outcome, and determining the technical and commercial viability of connected forklift as a service. That's a business outcome. Our typical engagement is between 3 to 6 weeks, which means to bridge the gap between proof of concept and prototype, we need to be extremely diligent in our planning, scoping, and the impact of each individual resource. And we need to be pretty scrappy as well. We cut lots of features, cut lots of scope, cut lots of process. In short, we cut lots of the product. We're not delivering production-ready solutions, but we do expect the prototype to be a catalyst for production, and ideally iterated on to become part of the final product. The goal of all this cutting is to de-risk our ability to deliver the business outcomes within the time allowed. In essence, what is the limited set of functionality required to provide the necessary data to support the business goals? There are things that can be left for the path to production, and things that need to be in place from the beginning, such as security, compliance, and repeatability. All too often, code from experiments make their way into production, like wildcard policies, and this puts customers at risk. There are things that we need to be relentless about. The tricky part is knowing where to strike the balance between agility and scope. So, how do we know what to cut? We use mechanisms that we define at the program level that guide our prototyping teams. Mechanisms are processes by which something takes place or is brought about, and when applied correctly, can create virtuous cycles that adapt and improve over time. Mechanisms are complete processes. Here are a few of the mechanisms or guiding principles that I believe to have the most impact on the success of our prototypes and provide the most confidence. Amazon is known for its customer obsession, and the mechanism used to stay customer obsessed is a process of working backwards. We apply this in everything we do. Our prototypes are no different. Before we get technical, we start with a business problem. We do discovery workshops with the stakeholders and executive sponsors so that we can deeply understand the business objectives that are trying to be delivered through the prototype. During this time, we refrain from discussing specific technology solutions as much as possible. The output during this process is a non-technical document that we call the solution space that clearly defines the problem statement and the business goals. We find that presupposing technology before we deeply understand the business space and the problem space limits our innovation. As an example, there was a previous customer looking for an ML solution to forecast commuter patterns in transit. It took over a week into development to dislodge this presupposition of technology assumption and realize that a much simpler, non-ML-based solution was much better, and the prototype had to pivot. We mentioned being scrappy, and 3 to 6 weeks is obviously not enough time to create a full production solution. So scoping is of absolute priority. But how we scope is key. The goal of scoping is to de-risk your ability to deliver the business outcomes within the short amount of time. Focus on the biggest rocks, the largest challenges of the business, and what has the most impact on achieving the business goals. Keep it simple. Don't over-innovate for the sake of innovation. Prototyping, by definition, is experimental, includes uncertainty and ambiguity, and like all innovation, has the potential to fail. Some failure is to be embraced and even encouraged, like the type of failure that retires poor approaches or technologies in favor of innovation and simplicity, those that push the boundaries on what is deemed possible. The type of failure that doesn't usually go over well is delivering something different than was asked for, missing the mark completely, not providing the data to support the goals. We strive to fail fast. Think big, but start small. Tackle the biggest challenges first. To achieve this, we continually validate our work against the solution space to ensure we are delivering on the business goals. Prototyping is about agility, momentum, and delivering results quickly. Prototyping requires a mindset of bias for action. But not all decisions are created equal. Some require you to slow down and make the right decision. So how do we balance between making quick decisions versus making the right decisions? We use the mechanism of one-way versus two-way doors. If we reach a fork in the road that we are uncertain about which path is correct, we first evaluate the impact of our decision against our ability to change it later. Decisions that are easy to change at a later time are considered two-way doors, while decisions that would require massive effort to pivot later are considered one-way doors. By quickly evaluating the impact of our decision in this way, we know where to spend our time fussing about the details. The key to this is not focusing on one-way doors, but rather to move quickly through two-way doors. Think of it like choosing software. If you can trial the software to determine if it meets your needs, that is a two-way door. But if you need to purchase it first, that is a one-way door. The final mechanism, or more of a philosophy, is prototyping as a program, not a project. Projects are bespoke, live and die, have little to no cohesion, and often have less impact. By institutionalizing prototyping at the program level, things like reuse and repeatability, governance and security become much more manageable and robust. Properly investing the time and resources into building prototyping as a program will foster a culture of innovation and promote high-velocity prototyping, which also provides the necessary controls. Okay, so that sounds nice, but may not sound like the prototyping you're used to. If we have all this process and governance, how do we stay agile? Where's the time for governance and compliance? Let's see if we can find a little time. An engineer doesn't need much to start developing a bespoke prototype in isolation. Once you have the business objective, the developer needs an account, some compute power, some storage, some simple tools, and good to go. But in big enterprise, things are different. Customers are constantly asking us, how do I maintain the freedom and rapid innovation the cloud brings my line of business, while introducing management and governance tools and processes to make sure I'm staying compliant, secure, and being cost-effective? We know that customers are looking for the ability to innovate with agility and control, but often think they need to decide between these. To support this, AWS offers a set of management and governance services that help our customers improve business agility and maintain governance controls. These services can support innovation, unclog provisioning bottlenecks, improve security, compliance postures, enhance operational efficiencies, and reduce costs. We at AWS are here to provide our customers with the tools that they need to innovate and modernize their businesses in the cloud while maintaining control. Through proper automation of the control and governance of your cloud infrastructure, you can actually unlock more agility during prototyping, while also reducing development time, risk, and cost. AWS has more than 15 services in the management and governance space that can enable your builders for more speed with built-in governance, provision applications and resources to meet your policies, and operate your environment with speed and governance. We don't have time to go deep into all of these. The key is striking the right balance between innovation and governance. We want to stay focused on prototyping. In terms of agility, the primary goal of management and governance is the automated provisioning of environments. Basically, how to get your prototyping engineers actually developing as quickly as possible, in accordance with your governance policies, of course. So, where do we get started? An AWS account provides natural security, access, and billing boundaries for your AWS resources, and enables you to achieve resource independence and isolation that can ensure your teams, projects, or products can rapidly innovate with their own security requirements, and helps isolate workloads and applications with specific security and compliance requirements. Ultimately, a multi-account AWS environment enables you to use the cloud to be much faster and build differentiated products and services, all while ensuring you can do so in a secure, scalable, and resilient manner. So, how should you build your multi-account AWS environment? The elements of building this are known as what's called a landing zone. In best practices, the landing zone should include multi-account management using AWS organizations, identity and federated access management with single sign-on, centralized log archiving, cross-account auditing, end-user account provisioning, monitoring, and notifications. Understandably, this may seem a bit daunting at first. Luckily, there is a simplified way to get started. The AWS Accelerator is a tool designed to help deploy and operate secure multi-account, multi-region AWS environments on an ongoing basis. The tool enables extensive flexibility and completely automated deployments of the customized architecture within AWS without changing a single line of code. Most importantly than the initial deploying of the solution is that it allows for organizations to operate, evolve, and maintain their cloud architecture and security controls over time as they grow with minimal effort. Think of it like giving your engineers a ring of keys to go-karts. They can get to choose the car, when to start and stop, and what they want to bump into. But you have limited this bumping to the guardrails defined by the course and the constraints of the go-karts. And my favorite part of AWS Accelerator is that it is implemented in CDK, which takes us nicely into our next area of focus. Now that we have seen how we can speed up prototyping through the organization lens with cloud management and governance, let's take a look through the developer lens and see what tools and best practices will bring even more agility and confidence. Let's see how much we can soup up our go-kart and improve our track time. AWS CDK, short for AWS Cloud Development Kit, is an open source framework to model and provision your cloud resources using familiar programming languages, such as Python, JavaScript, TypeScript, Java, and C#. This is seriously awesome. I like to call it CloudFormation for humans. I'm sure many of you have spent countless hours debugging CloudFormation dependencies in your large applications, only to find a misspelling in a reference. I know I definitely have. Now imagine an object-oriented language with classes and methods that is strongly typed, and it manages all the dependencies for you, making these types of annoying errors and many others a thing of the past. Not only do you get to use your own favorite programming languages, but you also get to use your favorite IDE and tools with the full support of the language and autocomplete, inline documentation, and testing. You can build abstractions and components of your infrastructure and application and reuse these between prototypes. CDK is much more than the abstraction of standard CloudFormation. It also provides abstractions on abstractions that supercharge your development and enable your team to start building prototypes more quickly and safely. This is a huge game changer in cloud development. The philosophy around CDK is moving away from the separation of infrastructure, application code, source code, and configs and deployments to a unified developer experience of the shared language support and toolings to truly full-stack development. In the context of prototyping, context switching can really slow down productivity. Switching languages, switching IDEs, and switching mental models all impede the agility and degrade developer ergonomics. Prototyping with CDK has really elevated our ability to develop quickly, especially with the ease of reuse and repeatability it provides. There are three main components of CDK: the core framework, the AWS construct library, and the command line interface. I want to focus on the AWS construct library, which is a set of components crafted by AWS to create resources for specific services. It is built with best practices, security, developer experience, ease of use, and fast iteration cycles in mind. Sounds like prototyping. The constructs are organized in three different levels. Level 1 constructs are automatically generated from the CloudFormation resource definitions. These are one-to-one mappings between classes and AWS resources, basically a type-check version of writing CloudFormation templates. Level 2 are higher-level service constructs that represent resources such as a bucket or VPC and include other resources. So this can be a composition of multiple resources, but still tied to one service. They provide sensible defaults and magic integrations and conveniences between AWS services like grants to manage access. Level 3 constructs are opinionated abstractions that are created either by AWS, third-party community, or your own libraries. This is the level where you will create your own abstractions that you can then reuse. In this example, maybe you have a pattern for secure REST APIs that uses Cognito and Lambda and API Gateway. And in the other, you string CloudWatch events into Kinesis. When developing your constructs, focus on efficiency rather than enforcement. Create abstractions with sensible defaults, but with the flexibility to customize as needed. The power of constructs is exponentially increased with the reusability and the open source community. There are some amazing projects like AWS Solutions Constructs and AWS CDK Patterns that quickly define solutions based on well-architected patterns and best practices. CDK Constructs really unleash developer agility and provide the level of control necessary for high-velocity prototyping. To illustrate this, let's create a simple application that has a public website hosted in an S3 bucket, and that's accessed via CloudFront. The website will send calls from the browser to the REST API hosted in the Lambda function behind an API gateway. The Lambda function makes calls to the DynamoDB database, very typical setup. Let's also assume that you can't create the website without a pre-existing domain name. We put the database and certificate in a separate stack and enable termination protection to make sure that we don't delete them and lose our data. That would be bad. Or we'd have to set up the certificate. That'd be annoying. We put the application and the front end together. We can also put multiple Lambda function in there as well, no problem. The S3 bucket is technically stateful, but we don't use it in such a way because it gets filled as part of the app. The dashboard depends on the other two stacks with generated names, so it goes into its own stack. Now let's see the CDK in action with some code for our sample application. First, we take a look at the monitoring stack, because it's the one that contains the CloudWatch dashboard that is used by the other stacks. It needs an easy abstraction for the other stacks to add graphs to the dashboard. We define a simple interface for that with an addsGraph method, and we create the CloudWatch dashboard resource. Next, we need to create the stateful stack, the stuff that we don't want deleted accidentally, like the DynamoDB table and certificate. The first thing we do is define the properties used to configure the stack. In this case, we need the reference to the monitoring to update the dashboard, and the domain name to create the certificate. Then we implement the class that creates the DynamoDB table with partition key, and conditionally, we create the certificate based on the existence of the domain name property. Next, we create the WebAppStack that implements the CloudFront CDN, the API gateway, S3 bucket, and our Lambda function. Again, the first thing we do is define the properties that configure the stack. In this case, we require monitoring again. The DynamoDB table is used to store application data, the domain name for the CloudFront, and the certificate, resources that were defined in our previous stacks. Then we implement the WebAppStack class, which is where we can really start to see the power of CDK come to life. Using a simple conditional statement in our code, we can enforce that the existing domain name and certificate must be defined together. We also define our Lambda function here. Look at the path. We can see that another huge benefit of CDK, based on its philosophy, the Lambda source code is defined alongside our infrastructure code. We also pass the DynamoDB table as a parameterized reference directly into our function and grant the function access to our table using some of that CDK magic of managing the roles for us. After adding the API gateway in S3 bucket, we are done with the initial implementation of our simple application. We could choose to stop at this point and let CDK generate all the necessary CloudFormation templates and assets, as well as handling the deploying of everything using the CLI. During prototyping, developers often rely on manual processes like this for building and deploying. Even if they are scripted and use CLI tools for convenience, they're not fully automated, as one would find in a production environment with continuous integration and deployment pipelines. Often, automation is seen as part of the path to production and avoided during prototyping, either seen as too complicated or too time-consuming, simply not worth the effort perhaps at this stage. To the contrary, through developing hundreds of prototypes, we have come to rely on automation, and CI/CD pipelines is a mechanism that actually improves our agility and increases our overall success of our prototypes. By reducing human error and providing repeatability from the beginning of our development, we find that through the lifespan of the prototype, we actually spend less effort and time overall by investing early in automation. Luckily, CDK comes to the rescue again with CDK Pipelines, which model continuous delivery pipelines as part of infrastructure as code, and simplify modeling cross-account and cross-region configurations. Even saying the simplified version of what that is doing sounds complicated, much less when you actually get in and try to implement it. Given this audience, I am sure that many of you have battled with this in the past. Keep those experiences from the past in mind as we walk through a quick example of how we deploy our sample application with CDK pipelines. Okay, so the developer pushes code to the repository and triggers code pipeline, which uses code build to synthesize the CloudFormation for the application. Then we self-mutate the pipeline based on any changes that were made. This is part of that CDK philosophy we talked about earlier. The application code, infrastructure, and pipeline all live in the same code base. Once the pipeline has been mutated, we move on to the publishing of assets, such as the Lambda code. CDK will store our Lambda code in an S3 bucket so that it can be referenced by CloudFormation when the actual deployment happens in the last step. So onto the code. We first define a stage, which is an abstraction from modeling multiple stacks that should be deployed together. In our stage, we define the property configuration, and in this case, the domain name. And we create instances of each of our previous stacks, the monitoring, the stateful, and the web app stacks, as well as pass the property references between these stacks, which CDK will manage the dependencies of for us. Now we create the actual pipeline. First, we create a new root stack for the pipeline and add a CDK pipeline instance to it. Then we model the production stages for the application and add them to the pipeline. Notice that each application stage specifies a unique AWS account and domain name used for the particular stage. That's about it. Now, when your team pushes changes to your source repo, it will automatically build and deploy your application. Next steps will be to add validation steps to gate propagation between your stages. But you get the point, much more manageable. And with that, you have introduced repeatability to your prototype. I hope that you started to see the benefits of how awesome and powerful CDK really is. But like all abstractions and frameworks, it is not perfect. And there are bound to be scenarios when it doesn't directly support your needs. Sometimes these limitations are CloudFormation itself. Other times, something more complex. Luckily, CDK has some powerful functionality at your disposal to escape from these potential pitfalls. Let's see an example of escape hatches to add to your arsenal. There are cases when the high-level constructs don't have the features that you're looking for. Sometimes a level 2 construct gets you 90% of the way, but you require modifying a single property. In this scenario, you can modify the CFN resource that is encapsulated by the level 2 construct directly. This gives you the benefit of the higher level abstraction, but with the low-level control sometimes required. Other times, a single AWS API call can fill the gap of the CloudFormation coverage. In this case, you can use the AWS custom resource construct. This construct creates a custom resource that can be customized to make specific AWS API calls for the create, update, and delete events. Additionally, data returned by the API can be used and extracted into your code. If the AWS API doesn't cover your needs, you can write your own custom resource. The AWS CDK makes it simple to write these and wrap them up in a regular construct interface. So from another user's perspective, the feature feels native. Building a custom resource involves writing a Lambda function that responds to a resource's create, update, and delete lifecycle events, which CDK abstracts away the complexity of it for you. Now that we have seen the power of CDK for reusability and repeatability through the developer lens, let's take a look at some quick wins by applying guardrails for compliance and security through that same lens. First up, we have CDK aspects. Aspects are a way to apply an operation to all constructs in a given scope. The aspect could modify the constructs, such as by adding tags, or it could verify something about the state of the constructs, such as ensuring that all buckets are encrypted. That means you could literally tag everything in one line of code. Next up, we have CFN Guard. This helps enterprises keep their AWS infrastructure and application resources in compliance with their company policy guidelines. CFN Guard provides compliance administrators with a simple policy as code language to define rules that can then check both for required and prohibited resource configurations. It enables developers to validate their CloudFormation templates against those rules. Before we wrap up, there are a few other projects worth mentioning that can speed up prototyping. JSII allows code in any language to naturally interact with JavaScript classes. It is a technology that enables CDK to deliver polyglot libraries from a single codebase. A class written in TypeScript can be used in JavaScript, C#, Go, Java, Python, and more. Supercharge your reusable modules by enabling them to work across your codebase. The CDK is much more than just CloudFormation. It is a set of design concepts and technology. The CDK's open source project is a supreme example of extending this technology. The project generates Kubernetes YAML in the same way that CDK generates CloudFormation, from construct extractions written in object-oriented familiar coding languages. Awesome. I'm a huge advocate of schema-first development. The API schema defines your contract between parties, whether it's front-end or back-end or internal and external. Following schema-first approach during prototyping speeds up development by decoupling stakeholders in your API. And the best code is code that we don't have to write. And GraphQL Code Generator supports full-stack development with some pretty powerful results. Try it out on your next AppSync API project. And last but not least, Northstar is a UI framework focused on prototyping at scale to easily design and develop your UI applications. It empowers you to rapidly prototype intuitive, meaningful, and accessible user experiences at scale. Definitely check it out. Wow, we covered a lot of material in a very short time. So, bringing this all together, we can see that to really drive business outcome from prototyping, we need some guardrails in place. And these guardrails, if applied correctly, actually improve our agility. By applying the right mechanisms, we make sure to drive business outcomes, not technology outcomes. And we navigate potential pitfalls along the way. By applying the right amount of governance at the organization level, we gain control, security, and compliance, while not compromising agility. In fact, we actually improve agility. And by fostering reusability, repeatability, and automation in our prototyping culture, we can scale innovation faster and with more control. Next time you're faced with deciding between agility or control, remember that sometimes you can have your cake and eat it too. Now go forth and prototype with confidence. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. Attend our instructor-led classes by qualified AWS instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Thank you again for attending. It was awesome sharing this time with you. We really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. And as always, happy prototyping.